My last video on this channel was about this janky Trackmania controller. It was a bit of a joke video. There was a lot of fun and silliness in it because this controller looks like it's just a roll of gaffer tape with a bit of a tripod attached to it and some weird circuit board on it, and that's, well, it's what it is. This is an Arduino Nano RP2040 Connect. It is the latest Arduino board, which has the Raspberry Pi Silicon on it. Very interesting if you are into things like that, as I am. But most of you are probably more interested in, the drivey, the Trackmania-y. And as I mentioned in the last video, I was going to do the summer campaign on this. I did about half of it, and it was very frustrating. So this video is more of a technical explanation video of how I did what I did before and what I have done now. Because in short, this looked a bit like a sort of janky, silly steering wheel, but it didn't have any analog steering. You would turn it like an analog input of a steering wheel, but it still would just be a keyboard. That's your right key, that's your left key for turning. It now does have analog implementation, and the way I did it was sort of a bit mad because at the time of doing this, neither the Arduino libraries nor the CircuitPython libraries have an easy way to emulate an Xbox 360 controller or an X-input controller. Or at least if there is, it is very well hidden. It is a time of change for both sets of libraries. There's so much new stuff happening that people are in the background frantically rewriting things because everything's happening very quickly. So this video is not quite as fun as the last one. This is a technical explanation of all of that stuff. If you're not into that, I am sorry. But before you leave, let's see this thing working the way it's meant to work. Now, the way this was working before is that when I turned this, it doesn't matter how much I turned it, it could be a tiny bit or a lot, it would just give me a binary output. I just had it set up for the keyboard. It was just sending keyboard commands. So left was keyboard left, right is keyboard right, and that's fine. I'm a keyboard player, I don't mind that, but it is very strange having a completely analog input like a wheel, or if I was just holding it like a motion controller. It is very strange having that, but the output not being that. So I have now implemented proper analog steering. This is now a proper steering wheel. You can do the full Grenadi, although it's not stuck to the desk. But you know what I mean? It's got the full analog input. It's the same as if you're using the analog stick on a controller. I will go into how I did that in a moment. But before I do, I know some of you won't be interested in the technical side of things, so I just wanted to sort of explain what's going to happen next, because I think this idea is compelling enough to actually try and make something out of. I feel like the idea of a dedicated Trackmania controller that works as a keyboard controller and a gamepad controller and a weird motion controller all in one would be a fun little project to make, and so that's next. And the next video in this series, as it were, will probably be me designing and making the enclosure. Because the enclosure is going to be this weird Frankenstein handheld device which has an analog stick. Because I have a bunch of different kinds of analog sticks like this. I also have a bunch of different kinds of buttons, so the idea is to really just smash them all together in a way that might actually make a nice controller. But the controller will have analog buttons on, but it will also have keys from a keyboard, because I have a bunch of brown switches left over. So this weird Frankenstein controller you could use as a keyboard controller or an analog controller, or both. Come off dirt, drive onto ice. Fantastic, but then you could just flick a switch on it and it becomes the full Grenadi. That's the idea. That's what I'm going to make next. So if you really just want to see the finished product, maybe stick around, maybe wait for that video. If you want to know how this is working, and it's not as trivial as it was to set up originally, then please do stick around and I will walk you through some of what it took to get this going. The full tutorial will have to wait for another day because there were so many weird little ins and outs and hoops I had to jump through to get this thing working, surprisingly, but it works. Before going any further, I know people are going to ask for the code, and I am going to give it to you in the description of this video. There are 2 paste bins for the 2 pieces of code you need. As both bits of code say, this is janky code that I threw together. The video explains how it works, but use it at your own risk or not at all. This video explains how you can do it for yourself and you'll understand it better. But if you just want the code, it is there, but I am not responsible if it turns your computer into an echidna. So, the code. I'm not going to explain every single element of it because I think that would be a waste of everyone's time. But needless to say, things like these booleans here, this is just stuff I put in for easy testing. It doesn't matter really that you know what they are. Kill stops everything working. Keep, do you have keyboard steering or not? That's it. Turn threshold and acceleration threshold. The acceleration threshold is how far this is tipped forward. So 3.5 is about here. That means that if this is tipped forward any further, the car is accelerating. If it's any further back, it is not accelerating. It doesn't mean it's braking, because that's the microphone. So a lot of this stuff is fairly standard CircuitPython stuff. Time and board. Time is just the Python library time. That's for getting delays and stuff like that. Board is everything you need to talk to the board itself if you want to have buttons, switches, inputs, outputs, including the onboard LED, things like that. We're importing the USB HID library. USB HID is what allows this thing to pretend to be a keyboard or a mouse. It's a human interface device. So is your keyboard, so is your mouse. These little boards, some, not all, but these little boards can pretend to be that, and that's how I started this whole malarkey in the first place. Keyboard and keycode are just really helpful little libraries that Adafruit provides to make it very easy to pretend to be a keyboard. Now this set of letters here, LM6M, this is the inertial measurement unit. This is the thing that knows what's happening with gravity, so it knows which way it's being tipped. Also, I'm not using it, but it has a gyroscope on it, so when you shake it, you can get a reading from it. I briefly set it up so the gyroscope was respawn, but yeah, that was so annoying because whenever I would just do that or get slightly annoyed and shake it halfway through a track, I'd respawn at the start, and it was rage-inducing. So audio bus I/O, this is for the microphone. Array, math, and utils, also for the microphone. They just need it. It doesn't matter. All of this stuff here is just useful functions that don't actually do specific things for the controller or for Trackmania. It's just things like getting the mean or translating values. This is mapping one value to another. So this thing goes from -5 to 5. The controller needs a -1 to 1. So this maps one value to the other, so I don't have to. This is a, hey, Stack Overflow, thank you, yoink. Same with a constrainer. We need to make sure that the value we give to the controller is never more than 1 and never less than -1, because it just doesn't make sense to it, so that does that too. Normalized RMS is a thing that came with the example code for the microphone. It just normalizes the sound. I don't argue. I copy, I paste, I'm done. Now, keyboards turning. This is what I was talking about before. X and Y are the gyroscope's X-axis and the Y-axis. And if the Y-axis in this direction is less than the threshold I want for it to start turning, that's when it will press the left key on the keyboard if we were using keyboard controls. We aren't doing that anymore, but that's how it used to work. Now, if not kill. If I want it to be working, it sets up the microphone. This is code I've just taken from the example code. It sets up the I2C sensor. This is the IMU sensor. And that particular library says to give a 1 second sleep here to stop race conditions. I don't argue. And we instantiate a keyboard for a USB HID devices. Now we do still need to have this pretending to be a USB HID keyboard because this movement to accelerate, this is just a binary accelerator. I think I agree with all Trackmania players when I say that you don't want an analog input for your acceleration. You want your acceleration to be there or not. There's no reason to have any analog acceleration. It's only turning that really matters. If anyone argues with that, please tell me why. So there's a 5-second grace period before anything happens, which technically I don't need anymore because I can kill things or not. But the idea of this 5-second grace period is just that if I need to get into game before it starts changing things in here, because what happens is basically it's like holding the up key down. So yeah, this just happens if you have it running, and it's very annoying. So the 5-second grace period gives me time to switch from codes to the thing. And then while true, X, Y, and Z are populated, 3 floats with the sensor acceleration values. This sensor, the IMU, gives an X value, a Y value, and a Z value. And depending on which way it's facing, it can give you values as to how much it is being tilted in those directions. I'm only using the X and the Y. And as I mentioned already, X is acceleration. If we are using keyboard turning, send that data to the keyboard controls, which is this function we just talked about up here. And then acceleration is always a binary, so it always uses the keyboard, so it doesn't need to use this if statement. If X is less than the acceleration threshold, because of the way this is facing, it's less is what you want. So this is higher than 3.5 or whatever it is, and then when it gets there, it gets below 3.5, and that's when you want it to accelerate. And if it isn't there, then release that key. Now this bit, weirdly enough, is where all the magic happens. This mapping here, this is mapped y as a new float that I'm making, and basically it's just taking the y value, which is between -5 and 5, and it is giving it a new value of between -1 and 1. So when this is at -5, turn it into -1. When this is at +5, turn it into +1. If, for whatever reason, the mapping goes a bit weird and there's ever a number that's bigger than 1 or smaller than -1, constrain it to those two numbers. So we're always going to get a number between -1 and 1, and then we just print it to the console. And that's all we're doing in order to get the analog values out of this thing. We're not making this pretend to be a gamepad. We're not having to fiddle around with USB descriptors. We're not having to write our own drivers, because there is no example code that works at this stage. CircuitPython will have some wonderful gamepad implementation soon, I'm sure. At this exact moment, I've even spoke to Dan, the guy who's doing it, and he gave a working example where you still have to write your own driver, but it's still... It still wouldn't work to emulate an Xbox controller, at least with my level of coding. I'm sure some of you out there could make it work all on the microcontroller. I decided to send it out via serial and then write another script on the main computer in order to feed that data to Trackmania, which we're going to get to in a moment. The rest of this is all just to do with the microphone itself. A microphone, it records in a set of samples, and then the magnitude is the normalized RMS of those samples over that time. This magnitude value is basically how loud has something been compared to the last set of samples, and you can set a threshold of amplitude to do something with. And so if the magnitude is higher than 200, press shift, which is my key for brake and drift. If it isn't, let go of shift, and then an arbitrary time delay, because that's the mic demo has an arbitrary time delay in it. That is all that the code does, and it isn't really all that much. And in all honesty, I took example code for USB HID keyboard and I smacked it in here. And then I took example code for the I2C IMU and I smacked that in here. Then example code for the PDR microphone, smacked them all in here and just stuck them all together in a way that I hoped would work. It didn't take a huge amount of creativity on my part to get this working. That said, I will clean this up and stick it on GitHub if anyone is interested. To me, though, the really interesting bit comes with how it gets from the serial monitor to Trackmania. The biggest issue I faced once I had the serial monitor giving me nice values was how on earth to make Trackmania think that was actually a joystick. There are multiple ways out there that you can actually emulate a joystick, but not all of those are very current, and a lot of them require extra third-party bits of software to take those inputs, and then once you've made them appear to be some kind of joypad, then they will be turned into Xbox 360 commands, which are recognized virtually by the computer. It's like via emulation. Yeah, there's a lot of steps to it. And then I discovered PYX input, which does all of it in one go. This is a work of art. This library, which may be a fork of another library, which may be a fork of another library, works on the most current version of Windows 10, and essentially, there's a few instructions and a few hoops you need to jump through to get this thing running. You need to install SCP Bus if you want to use the virtual controller object, which I did. It took a bit of fiddling to get going, and I can't honestly tell you exactly the steps that I took, and it might be slightly different for you anyway. However, there are various ways that you there are a few things you need to do, and once you have, it just works. It just works wonderfully. Which brings me on to my very janky test code. So this uses the Pi serial library, which is a simple serial reading and writing library. It doesn't do anything massively fancy that I can see. The thing I like most about it actually is that it just seems to be very simple. And so this is example code that I have just taken from them. So the first thing I have done here is created my own virtual controller. My virtual is a virtual controller. Again, this is example code. I copied it. It worked. My serial is serial.serial. COM8 is the COM port that my Arduino is on. I know that because I looked at my device manager. And this is all, again, the stuff that was in the example. The only thing I've done that's different is I've chucked everything into try excepts. Just because it's good practice. So try to make the serial port happen. If for whatever reason it can't, print an exception, cannot make serial object. I'm not handling errors properly. I'm not making them quit. It just means I can see what's going wrong at what point. And then there's just a simple loop. While true, try and parse the serial data. So read the serial port, read 100 characters from the serial port, and take that serial data. If there is serial data, so anything larger than 33 bytes is a byte array with content, basically. So don't bother with it if it's blank. If you read the serial port and nothing has been sent, just throw it away. If something has been sent, decode that serial data, and then that will give you a number. And then try to turn that number into a float. This is a very important try except, because sometimes when it's really firing things through quite quickly, data will come together bunched, and you'll get this weird combination of numbers and carriage returns that I could handle. I could do that, but to be honest, I don't need to. This is all happening so quickly that I don't think it's an issue, and I think it could run a lot faster and still, I haven't noticed any appreciable difference in the steering, and I haven't got this running nearly as fast as I wanted to yet, so that's something to maybe come back to later. But basically, if you can make a float of it, then this is when we get into the dead zone. In general, if it is turning, if the wheel is turned, send that value to the virtual controller, which sets the axis, which sets the thumbstick on the virtual controller to be left or right. The dead zone, just like in any video game, the dead zone is how much in the middle of that controller does nothing. I'm sure some of you have had that really annoying problem where you've got maybe an old controller and the dead zone's too small and things wander a little bit to the left and right when you're not even touching it, so you can up the dead zone to stop that happening. I have made my own dead zone, a dead zone of 0.15, which is maybe big to some people, I'm not sure. And that means that when I'm in that 0.15 range here in the middle, all it will send is a 0. Keep the car straight. If it's higher than the dead zone or lower than the minus dead zone, so higher than the dead zone or lower than the minus dead zone, turn. Otherwise, set it to 0. That is it. This library is incredible. So this is where we've got to, and if you stuck with me for this long in the video, thank you very, very much. This controller is actually working rather well already. Don't be put off by the terrible driving on my part. I am talking and driving at the same time, and not the best driver anyway, especially when using weird analog motion controls that I only invented today. This thing already feels pretty nice, and it's not even running as responsively as it could be. I could run this code an order of magnitude faster, and therefore get more inputs, per tick. But it already feels pretty good. So the next plan is to get this thing housed, make a mad controller which is analog and keyboard and motion, stick it in a box, and see what it feels like to use. And that will be a nice way to draw a line under this part of the project. When I get there, I will happily make a tutorial from start to finish as to how I made it, because obviously this could be used in other games. And if anyone would like a custom Trackmania controller, I'm sure I could rustle one up for you. We'll just have to talk about that. But next plans for mad things to do with Trackmania. Well, I have many, and I don't want to spoil all of them. I want some of them to be a bit of a surprise. But two things I will go into. I've already once previously mentioned that I think controlling Trackmania with your eyes would be hilarious. And so that's what I'm going to do. I have already got started with a script and, well, a library that uses a script that, where the hell am I driving? That's fine. A library that uses a script that tracks your eye motion on the screen. It uses that data to give you an idea of where you're looking in both left and right and up and down. Now, once again, there's issues with using some of those things for acceleration and turning, but we'll make it work. And I think that a version of Trackmania where you cannot look where the track goes, you can only look to the left and right of the screen in order to turn the car, and you have to look at the track through your peripheral vision, is horrible. Here's another thing I've been thinking about. Using the same principles that I've used in this, you could take any stream of numbers and you could use that as an analog input for acceleration as well as turning in Trackmania, because there is an analog acceleration in Trackmania. You want it to always just be as fast as possible. But what if you had a stream of numbers and that number had to stay above a certain threshold in order to have maximum acceleration? And what if that stream of numbers was determined by using the Strava API and looking at how fast you ran on your last run? I don't know if that's a good idea or pure evil. Anyway, that is the end of this video. There is no call to action. Have a wonderful day.